Good morning, Istanbul. Thank you for being here. In the next few minutes, I'd like to share our view on, expand on what Callan just mentioned about the Internet of Things, and share our view on the opportunity that the Internet of Things represents for the industry. And then also, I'm going to show you what Autodesk is doing in this area. So let me first provide a little bit of context of the industry forces that are driving the explosion of the IoT. Customer demand is actually driving the IoT. Customers want more connected experience, want the products connected to each other, enabling new scenarios that weren't possible before. They also expect products that get better with time. They expect hardware products to become better with software upgrades. And they don't have the same attitudes towards ownership that we had in the past. So things like Uber and Lyft and Airbnb, those models are actually starting to bleed into other areas of the industry where people don't necessarily want to own products. There is also a growing interest from manufacturers to connect their products in order to enable extended services. In fact, in some segments of the industry, like industrial machinery, this has become a competitive differentiator to be able to add attached services. And services have always existed in the past in various forms, service contracts and et cetera. But what's changed is that with the explosion of the IoT, manufacturers can see how their products are performing and are being used 24 hours a day, 7 days a week, and the insight that that data can bring and the computing power of the cloud takes the ability to provide services to a whole new level that wasn't possible before. So, as is common in any disruptive, hot technology, there are many definitions for the Internet of Things. This is the one that we use just as a very simple one. The Internet of Things refers to the network of devices connected to the Internet that can collect and exchange data. Very simple and general definition. It's not here, but it also, when we refer to the IoT, at least in Autodesk and at Autodesk products, we are actually referring to the industrial IoT as opposed to the consumer IoT. So we focus our IoT discussions on industrial machinery, specialty vehicles, and things like that. So why is there such an explosion of the IoT? What has accelerated the IoT? So basically, it's thanks to the declining cost of 4 key technologies. The first one, sensors. So sensors, the prices of sensors have dropped dramatically. If you take one particular sensor that we looked at in 1997, it was $22. Today, it's 40 cents. So you're seeing orders of magnitude in the drop of prices of sensors. Now, the second one, we have small embeddable computers, like you can see in this slide. You have small chips that have Wi-Fi or have Bluetooth in prices that are $19, $5, $39. Those were prices that were never seen before. And of course, the third one is the explosion of wireless networks, which makes it possible for everything to be connected pretty much everywhere. And fourth is the explosion also of the cloud and the availability of cloud server farms. So those are the 4 things that have accelerated the IoT in the last 5, 6 years. So let's look at what is the opportunity of the IoT for industry. So this is an interesting figure that kind of gives you a sense that it's expected that $50 billion devices will be connected by 2020. 2020 is only 4 years away. I mean, in fact, a few years ago, around 2008, the number of things connected to the internet exceeded the number of people connected to the internet. So this is how we're seeing, just in orders of magnitude, the size of the opportunity. I like this couple of things from GE. By 2020, the industrial IoT will comprise roughly 60% of the gross domestic product. And Jeff Immelt, the CEO of GE, has this interesting thing to say. If you went to bed last night an industrial company, you are going to wake up today as a software and analytics company. So, and GE is actually embracing this new trend of software, the convergence of software and hardware. So let's look at the main opportunities of the IoT. So first, for those that are implementing IoT in their own operations, the most obvious one is cost savings. So those cost savings come in two flavors. One, because by doing things, by constantly monitoring your devices, you can do things like predictive maintenance, and that, of course, reduce unpredictable downtime. So for example, these are a few figures from GE also. The typical savings for doing predictive maintenance in a crusher is $120,000 US dollars, in a pump, $62,000, in a whole truck, $60,000. Those are savings only from doing predictive maintenance on those machineries. And the other is because the second source of cost reduction is that because you are constantly monitoring your device, your product, you can tweak the performance parameters to optimize the operation, and therefore you'll be saving energy, you'll be saving, again, poor performance and things like that. The second opportunity from the IoT is that, obviously, is the ability to connect your products, and this allows manufacturers to deliver enhanced customer experiences. It also, with the inside of that data, the manufacturer can do great things. They can do provide attached services like we described, but they can also, because they're connected now, they can do things like upgrade the software in the device wirelessly. And even further, this connectivity allows the manufacturer to offer new business models that differentiate them from their competitors. So for example, here shows a product as a service model, which is basically where the customers of the manufacturing company, they subscribe to your product, and they pay you by the uptime or the outcome. For example, in this machine here, this is a machine that basically moves dirt. Customers could pay by tons of dirt moved instead of by the machine itself. So that's known as product as a service, and is enabled in big part by the IoT. Another interesting opportunity from the IoT is that by being connected, your products can send data to you of how it is being used by your customers. So this data can provide significant insight of how frequently some features of your product are being used, what are the parts that are breaking more often, and even some opportunities to upsell other products and services to your customers. And last is what Callan mentioned before, is the opportunity. By being connected, you can feedback this information to the design department to optimize the design. So this is the cool example that Callan was providing from the Bandito brothers, where IoT was used to improve the design, the next generation of the design. So we started with this design of this road car. This was the original chassis. We connected sensors all over the place. And then we tested it, again, like Callum mentioned, with a real driver under different situations. And all the while, we collected approximately 4 billion data points from these tests. And all those data points were input into our generative design algorithms. And this algorithm designed the next version of the chassis, which you're seeing in the video. And the final result was something like this. So the version of the left was designed to be printed in a metal called chromalloy. And the one on the right was optimized to be printed in titanium. So these generative design algorithms also consider the final material or manufacturing processes. Excuse me. So how do some of your peers see the opportunity in IoT? So we recently, last August, we conducted a study of IoT in roughly 300 mid-market and small manufacturers. And it shows, among other things, that almost 60% are working on their first IoT product now or in the next 24 months. So we were surprised by that. Almost 60% are considering IoT in the next couple of years. And of those, most cited competitive differentiation and new revenue as the driving force for connecting their products, for putting their products in the IoT. Okay, let me shift gears a little bit, and let me tell you something about the types of analysis that you can perform when your products are connected. So the first one is looking at the past. So what happened? So this is mainly about parsing through historical information, typically in a time series data like you see here, and basically to explain the past. So right now, almost 80% of the business intelligence market is in this type of model, in descriptive analytics. The next one, the second one, is to look at the present. What is happening now? So this is about continuously ingesting and analyzing data and raising alarms or messages depending on criteria that you specify. So for example, you have this machine here, and it could tell you that the service is overdue because these 3 components have been working for more than 120 hours. Or it could give you an alert because saying something like the motor's RPM is above limit. So this is what's happening right now. And of course, the third logical step is to look at the future. What is likely to happen in the future? So there are several approaches to do this: regression analysis, Monte Carlo simulations, but one of the most interesting ones that we are using is machine learning and artificial intelligence. And we are working on adding also decision support. Okay, you know what's going to happen, that tomorrow this is going to happen. What should you do now? So some decision support. Excuse me. So that is the overview of the IoT and the opportunity in the industrial sector. So what is Autodesk doing in this area of industrial IoT? So we have a relatively new acquisition that is our IoT solution. It's called Fusion Connect. Fusion Connect is a cloud-native, no coding, agnostic to any protocol, communication protocol or transfer, that allows you to connect to products, collect the data, analyze it, and takes decisions on the data. So this is a glimpse of how it works. So the platform comes with a very large number of adapters to the most popular transport protocols in industry. And also, if you have a protocol that is not in the group, it's very easy to add new ones. And without having to write any single line of code, you can connect to the products and analyze it and build dashboards. So let's take a look at Fusion Connect in action. In this example, this is an example of a company that has these rollers all around the San Francisco area. And each roller is sending information about its performance and environment. And this data can be displayed in real-time dashboards that allow you to quickly see if something needs attention. More recently, we are complementing our IoT product offering with something called dynamic predictive analytics capabilities. So dynamic predictive analytics is an artificial intelligence modeling engine that extracts meaning from large data sets and delivers prescriptive solutions. So this enables manufacturers to understand what's going on, but also to predict what is likely to happen tomorrow, a week from today, in 10 days, and make decisions. So this capability is available now at Fusion Connect, and it comes from a company called Newtonian, and the product is called Eureka. So it's a predictive analytics capability. Our IoT capabilities, we are building something larger, which is Fusion. It's called Fusion, and it's our product innovation platform that basically has Fusion at the center, and all around the platform has all the capabilities for design, make, and use. And particularly in the use capabilities is where we are going to put all of our IoT capabilities. The capability that is now in Fusion Connect is going to complement the product innovation platform. So by having everything together like that, it's much easier to do things like using your IoT data in design, or designing products that are going to be connected, where all the data and all the environment is consolidated like that. So to conclude, at Autodesk, we understand the challenges that our customers face in this new era of manufacturing. And we are keenly aware of the opportunities that are at stake. So we believe that with our understanding of the opportunities and our culture of innovation, that we are uniquely positioned to take customers into this new era. In fact, since our beginnings in 1982, we've helped customers through 2 major disruptions already. So when 2D drawings moved to the computer, this disruption started what we call the era of documentation. And we led the way in this era, particularly with our first product, AutoCAD, back in the 1980s. Basically, in this era was document the designs. We were using the computer basically as an electronic drawing tool. And we generated the manufacturing instructions manually. And then if there was any modification, sometimes we didn't make it back to the model. As computers and software got more powerful, we moved 2D to 3D into what started the era of optimization. So this era was much more about just documenting our products. It was also about visualizing them, optimizing, even before a prototyping was ever built. And things were a little less manual. We could generate the manufacturing instructions from the 3D model. We are currently entering into a third era that we call the era of connection. This is marked by the emergence of the cloud and the push of connectivity among people, things, and places. And in this era, design transcends the definition of the 3D model. We also model the connections among products, people, and places, and things are designed with connectivity in mind from the beginning. In this era, we'll be able to see in real time how our products are being used by your customers. And we'll be able to see in real time what's happening in the manufacturing floor and feed that information back in design. And we are positioning ourselves to be the disruptors in this area. So let me conclude with this video about the era of connectivity,
where the methods of production, consumer behavior, and even the nature of products is changing dramatically. This rapid transformation is changing the way people design, make, and use products. Autodesk is embracing this disruption and building the tools that will help companies thrive in this dynamic new world. At the heart of this transformation is the Internet of Things. IoT refers to the growing ecosystem of physical devices embedded with sensors and software that connects them to the Internet and to each other. It's having a massive impact not only on consumer products, but also on machine manufacturers who need to meet their customers' growing expectations for online services. Autodesk C-Control is helping manufacturers make connections between their products and their customers. Powered by the industrial Internet of Things, data can be captured, analyzed, and managed. Building a better understanding of how customers use products and services, informing improvements on next-generation innovations, enhancing customer experience and delivering a whole new level of service, transforming business models and creating new streams of revenue. C-Control is a cloud-native solution that offers a no-coding, point-and-click approach to IoT that makes it fast and easy for manufacturers to build smart, connected products. The future of making products is connected. Get on the fast track to IoT.
So with that, that concludes my presentation. I'd like to leave you with this thought. If you are a manufacturer of industrial equipment, specialty vehicles, I mean, not to mention, of course, consumer products, but in generally industrial machinery, and you don't connect your products and enable connected services, your competitors will. So I hope that with this presentation, I got you interested and excited about the opportunities of IoT in industry. So with that, thank you very much. Enjoy the rest of AU and have a great day. Thank you.